Right, we're going to look at the Euler-Cauchy formula. Okay. We use this method for the equations of the form Ly equals a2x squared y double dash plus a1 to the x y dash plus a0 y equals g of x, where a2, a1 and a0 are constant values. Looking at an example where g of x, which is a homogeneous equation, so we're going to use x squared y double dash minus 4xy dash plus 6y equals 0. We first apply the trial solution, which is y of x equals x to the m. Differentiating this, we get y dash equals mx to the power of m minus 1, and again y double dash equals m times m minus 1 x to the m minus 2. We then apply this to the original equation, so we get x squared m minus 1 x to the m minus 2 minus 4x x to the m minus 1 plus 6x to the m equals 0. This cancels down to m times m minus 1 x to the m minus 4m x to the m plus 6 x to the m equals 0. Again, we cancel this down to m times m minus 1 minus 4m plus 6, all times by x to the m equals 0. As this equation is true for all values of x, the first part must always equal 0. Therefore, m times m minus 1 minus 4m plus 6 equals 0. This goes to m squared minus 5m plus 6. We factorise that, gets us m minus 3 times m minus 2. This gives m values of 2 and 3. Therefore, the general solution is ax squared plus bx cubed. The a and b values for a particular solution can be found using any specific conditions from the question. Therefore, sub in 1 equals 0, y dash 1 equals 1. So we get a1 squared plus b1 cubed, and that gives us a plus b. Therefore, a equals minus b. So y sub in x gives us 2ax plus 3bx squared. Subbing in the 1 gives us 2a1 plus 3b times 1 squared, which equals 2a plus 3b, which equals 1. Since a equals minus b, this can be written as and therefore hence b equals 1 and a equals 1. This gives a specific solution y of x equals minus x squared plus x cubed. The m values found by applying the trial solution to the original equation dictate the form of the general solution. So if m equals alpha beta, where they don't equal the same thing, y of x equals ax to alpha plus bx to beta. Like the example just seen, we can put, say, m equals alpha, that's a double root. Y of x equals a plus b ln x times x to the alpha. When we're dealing with complex roots, do p plus or minus iq. Therefore, y of x equals a sine q ln x plus b cos q ln x, all times by x to the p. We then solve this for a and b as before. If g of x does not equal 0, the trial solutions would be in the form of g of x. So for the example, it would be x squared y double dash plus 7xy dash minus 9y equals x to the 7. We then try solutions. Y of x equals x to the 7. Y of x equals ln x all times by x to 7, or y of x equals ln x squared times by x to the 7.